This is a standard 3D print. It works, but let's be honest, it's also a little bland. What if you could turn it into this stunning, custom engraved masterpiece? Now, I spent dozens of hours figuring out the perfect settings for engraving every type of 3D print, from basic PLA to carbon fiber. And in this video, I am sharing everything I learned so you can skip the frustration and start making these incredible projects today. Let's be real for a second. 3D printed text usually sucks. Best case scenario, you get something that's fine, but it's never great. And embossed text looks clunky and snags on things, and debossed text is a magnet for every speck of dust in your workshop. And adding color, now that's just a whole nother world of pain. You're either stuck with slow, wasteful filament changes, or you're running a complex, expensive, multi-material setup. And for a hobbyist or someone selling prints, it's just too much time and too much waste for a result that still does not feel professional. And this is where a fiber laser shines. Unlike the CO2 or diode lasers that many of us have, which just melt plastic into this gooey mess, a fiber laser operates at a specific wavelength, around 1064 nanometers. And that's perfect for this job. Instead of just melting the surface, its energy is absorbed by pigments and additives in the plastic, causing a localized reaction like foaming or carbonizing. This creates a super high-speed, high-contrast mark. So I set out to create a definitive guide. I printed 45 test plates across a huge range of materials: PLA, ABS, PETG, and ASA. And then came the cool stuff: carbon fiber reinforced filaments, glass fiber, and even the notoriously difficult flexible TPU. And my mission was to find the ideal settings for all of them. To do this right, you need a system. Just guessing at settings is a recipe for disaster. So I designed this, the test grid. I printed dozens of these plates, each with a 7x7 grid. This grid is our roadmap to the perfect settings. On one axis, we have laser power from low to high. On the other, we have laser speed from slow to fast. And each of the 49 squares on the plate is a unique combination of those two variables. By engraving this grid onto every material, we can see exactly how it reacts and pinpoint that one perfect square. Now, this process took a ton of time and a small mountain of filament, but I did the work, so you don't have to. Now, the goal is to build a playbook we can all use to get great results every time. I'm curious, have you ever tried lasering your 3D prints? Let me know down in the comments what happened: the good, the bad, and the melty. All right, before we jump into the data, a quick shout out to PCBWay for sponsoring today's video. Their support is what lets me run a massive test like this and put the results out for free. Now, if you're working on anything custom, PCBWay isn't just PCBs anymore. They can do CNC machining, 3D printing too, including SLS, resin, and FDM printing. Now, the reason that matters for this video is a lot of those printed materials have the potential to laser really well, which you are about to see, and I will point out the best ones along the way. So if you want to check them out and support the channel, the link is down below. Now, let's get into the results. This is where things are going to get really interesting. First up, PLA. It's the most common material and also one of the trickiest. As you can see from the grid, PLA is very sensitive to heat. Too much power or not enough speed, and you get a burnt, melted blob. The sweet spot is a tiny window of really high speed and pretty low power. On lighter colors though, the effect was almost invisible. Next, ABS and ASA. Now, these plastics are more temperature resistant and they behave much more predictably. The window for a good engraving is a lot wider than that of the PLA, and they both produced clean, sharp marks, with ASA having a slight edge in consistency. Now, for my personal favorite for this process, PETG. It's tougher against the heat than PLA, and the results from the test grid were fantastic. Unlike PLA, which mostly just foams up and turns white, PETG can produce a range of effects. Some settings give you a light foamed mark, and others create this clean, dark score. And this dual effect potentially makes it versatile for creating designs with different shades. But then we have our composites, carbon fiber and glass fiber. Now, I was really excited about these. You're not just engraving plastic, you're engraving a composite, and that changes the whole system. The carbon fiber PETG produced one of the best results of the entire experiment. The carbon fiber fill performed the best out of all materials, honestly, but it was largely dependent on the base plastic and pigment. But finally, TPU. Now, this is a flexible, rubbery material, and as I expected, it was odd. The clearer pigments allowed the laser to pass through and mark my laser bed, which I'm not happy about. But the darker pigments burned in a very high contrast and high detail manner, meaning this material was more dependent on pigment instead of shore hardness or the material. So now we're getting to the good part, turning this data into actual projects. Now, if you're getting value from this and you want to see more experiments like it, make sure you're subscribed. It's free and it helps a ton. Okay, enough test grids. The whole point of this was to use these dialed in settings to make awesome stuff. So let's do that. Now, my workshop is in a constant state of chaos. I have hundreds of little drawers for screws, electronics, and printer parts. I printed a bunch of simple drawer organizers. I checked my PETG test grid, picked the settings for the cleanest, high contrast text, and loaded the file. And in just a few seconds per drawer, I had a perfectly crisp, permanently labeled bin. All of these are M3 based at different lengths. And it's so satisfying. That's what this all is about, taking a simple functional print and making it way more useful. Project 2, the maker coin. Now, for something more fun, I wanted a maker coin, like a personal calling card. And for this, I had to use the carbon fiber PLA. The results on the test grid were just too good to ignore. So I turned to one of the most controversial technologies of the modern era, generative design, and I had it create me a little tiny piece of Pisces printing art to go on my coin. I'm not a 2D artist, I'm a 3D artist, and unfortunately I'm not good enough at 2D art to make something like this. But with the design in hand, I sent it to the laser software, dialed in the settings, and watched the laser work on the carbon fiber PLA. It's absolutely mesmerizing. The galvo mirrors are just a blur, that it's just all the way across, and the design almost appears instantly. And the final coin is just as stunning. It has this unique textured finish where the laser hit the fibers, and it has a level of detail my 3D printer's nozzle could never dream of. Finally, to really test the limits of detail, I decided to engrave a complex pattern on a simple object. I printed a flat bookmark using black PETG. And we know from our tests that PETG has the best chance for a wide color range. I carefully chose my settings from my test grid and used a PNG picture that would be totally impossible to 3D print. The laser danced across the surface, and honestly, the result is perfect. Every tiny line and swirl is cleanly etched, and this is what happens when you stop guessing and start using data. We took a 20-cent piece of plastic and turned it into something that looks genuinely artistic. After 45 test prints and hours of lasering, what is the takeaway? First, every filament is different. Not just the type of plastic, but the color and brand can dramatically change the result. So you always have to run a quick test. Second, a fiber laser is an amazing tool for this job. It gives you the speed and control to create sharp, high contrast marks without just melting everything. Thirdly, materials like PLA and TPU can be finicky, and plastics like PETG and ASA, and especially carbon fiber filaments, can produce absolutely incredible high-end results. And we went from bland, generic plastic parts to these permanently labeled organizers that have already made my life easier, a stunning carbon fiber coin that feels like a collector's item, and a bookmark with detail so fine it looks store-bought. And my goal was to take the guesswork out of this for you. I'll make the full list of materials and the exact settings that worked best available in the description below. Now, for the next video, I'm thinking we might move back to speakers. I'm not sure. Let me know in the comments what you want me to do. Do you want more laser stuff? Do you want more speaker stuff? Do you want me to try a third unnamed project? Either way, let me know, and thanks for watching.